So in the last video we solved some multi-step equations, but they were just algebraic equations with no words. They were not word problems, so we're going to try to do a word problem that involves solving multi-step algebraic equations. So we have Andrew and Marvin, and they helped set chairs in rows for a spring concert. They put the same number of chairs in each row. Using the 92 chairs available, Andrew made 4 rows with 2 chairs left over, while Marvin made 5 rows with no chairs left over. How many chairs were in each row? So at this level of algebra, if you're in pre-algebra, or even if you're in the first half of the year of Algebra 1, you can pretty much assume that every word problem is going to be a linear equation. You might get into quadratics later, but for the most part, when you see these type problems again in pre-algebra or Algebra 1, in the early parts of Algebra 1, it's always going to be a linear equation. And in all linear equations, well, not all linear equations, but in most linear equation word problems, you'll have a rate, and that's usually the most important thing to identify first. So in this case, we're looking for, what is a rate? It's something per something. It's a ratio. And this, when we browse through here, there's 92 chairs. That doesn't look like a rate. 4 rows. That doesn't look like a rate. 2 chairs left over. That doesn't look like a rate. 5 rows. That doesn't look like a rate. And then finally, they say how many chairs were in each row. So it's how many chairs per row. So what we're actually solving for is the rate. So the rate is equal to question mark, because that's what we're solving for, and that's chairs per row. And then now we can go through and try to translate each of these sentences. Going to this line here, this third sentence, it says using the 92 chairs available. So that tells us there was a total of 92 chairs. And then it said Andrew made 4 rows. So we can say, we'll say over here, Andrew, he made 4 rows. And if you notice, I'm listing everything, even if I don't have the value, with the unit of measurement. And the unit of measurement is extremely important, because when we construct our algebraic equations, the unit of measurement will be a great check to see whether our equation makes any sense. So he also had 2 chairs left over. So we can say there was an extra amount, and we'll do a subnotation. E sub A is equal to 2 chairs. And then Marvin, he made 5 rows. So, whoops, let's say Marvin, he had 5 rows. And then he had no extra chairs. So we could technically say E sub M is equal to 0, but we don't really need to do that. So let's go ahead and try and construct our equation now. So let's say we did know how many chairs were in each row. Let's say it was 5 chairs per row. Well, if it was 5 chairs per row and Andrew had 4 rows, well, how many chairs would that be for those four rows? It would be 4 times 5, and that would be 20 chairs if it was 5 chairs per row, which we don't know. But what we can do is we can say, well, we don't know the number of chairs per row, but we know we're going to be multiplying R times A in the same way, that we'd be multiplying if it was 5 times 4, if it was 5, which we don't know. So we can say, well, we have R times A, and this R times A represents the number of chairs that would be in all the rows that Andrew set up. And then we could make that same argument and say R times M. That is also the number of chairs for the 5 rows that Marvin set up. And then we could say plus there's 2 extra chairs, and that's going to be E sub A. And then that's equal to the total amount. So when we set up our equations, the important thing to look for is how many terms that you have, and you want to try to understand what each term represents. And the important thing to remember is every term needs to have the same unit of measurement. So the T clearly has a unit of measurement of chairs. Well, e sub a, that also has a unit of measurement of chairs. So these terms look a little more strange. So let's see if that checks out. So the unit of measurement for r is chairs per row. And what's the unit of measurement for the a? It's rows. And then we have for this term, same thing, we have chairs per row times rows. The unit of measurement for m is rows. And then for e sub a, the unit of measurement is chairs. And then the unit of measurement for t is also chairs. So again, if our equation actually makes sense, then the unit of measurement for each term should be the same. So right now it doesn't really look like that, but if you look at this term, the unit of measurement for this first term, r times a, well, it's chairs over row times rows. Well, this is actually rows over 1, so this row over row can cross off. Same thing with this one. This row over rows can cross off. And what are you left with? You're left with chairs as the unit of measurement for this first term, chairs for the unit of measurement of the second term, and then chairs for e sub a, and then chairs for t. So we have chairs plus chairs plus chairs equals chairs. And so that means we can trust this equation, because what will happen sometimes is people will say, well, I think it's maybe r plus a plus e is equal to t, but this doesn't make any sense, because what's the unit of measurement of r? It's chairs per row, and then plus rows plus chairs equals chairs. And this makes no sense, because the unit of measurement for a is rows, unit of measurement for e is chairs, unit of measurement for t is chairs, and none of these four terms have the same unit of measurement. And the cardinal rule is, when you're setting up your algebraic equation, the unit of measurement for each term needs to be the same. And quite frankly, I don't think this is really emphasized in a lot of schools, middle schools or high schools. I know it's emphasized a little bit more, at least when I was an engineer in college, it was emphasized a little bit more. So I think if you understand this early on, it'll make your mathematical career through middle school and high school a little bit easier. So anyway, getting back to the problem, let's erase some of this so we have some more space. Let's get rid of this. And then we will also get rid of this space right here. Okay, so now that we've done our unit of measurement check, we can just substitute in our values. So we don't know what r is, that's actually what we're solving for, but we do know what a is, and that's 4. And then we, again, don't know what r is, but we do know what m is, and that's 5. And then e sub a, we know what that is, that's 2. And then the total number of chairs is 92. So again, just to recap, r times a, this term represents the number of chairs that Andrew set up. This term r times m represents the number of chairs in the rows that Marvin set up. And then this is the 2 extra chairs, and that total amount is 92. So what's the goal of this math sentence? Well, it looks a little bit weird, and that's because this coefficient is in the back. So we rewrite it as 4r plus 5r plus 2 is equal to 92. Now it looks a little bit more familiar. And we just, at this point, combine like terms. So 4r plus 5r is 9r. Plus 2 is equal to 92. Goal of this math sentence is to get the variable by itself. And what's causing us that problem? A 9 and a 2. So it's easier to get rid of the other term versus getting rid of the 9 factors. So we're going to subtract off this 2. And what gives us the right to do that? We subtract it from the other side. And then when we do this, what are we left with? We have 9r is equal to 90. And then let me scroll down a little bit so I have a little more space. So the goal of the math sentence is to get the variable by itself, and we have that 9 coefficient, so we want to divide that off. And so we have to do that to the other side, and then r is equal to 10. But 10 what? and we just go back to where we started here. It's 10 chairs per row. So it's 10 chairs per row. I hope that helps.